Mic test Ahem. This is CPU scheduling algorithm made by Jeremy Cristobal and Kim Davina, and I'm your guide Daisy. Let's start. CPU scheduling algorithms. Many criteria have been suggested for comparing. This includes CPU utilization, throughput, turnaround time, waiting time, response time.
CPU utilization. This measures how busy is the CPU. Throughput. This is a measure of work, number of processes complete. Turnaround time. This measure how long it takes to execute a process. Waiting time. Total amount of time a process spends waiting in the ready queue.
Response time. The time from the submission of a request until the system makes the first response. The CPU scheduler selects a process from ready queue and allocates the process to CPU. The scheduling which takes place when a process switches from running state to ready state or from waiting state to ready state is called preemptive scheduling. On the hands, the scheduling which takes place when a process terminates or switches from running to waiting for state. This kind of CPU scheduling is called non-preemptive scheduling. Non-preemptive scheme formulas. Waiting time equals time started, arrival time. Turnaround time equals time finished, arrival time. Throughput equals number of process completed, total time to finish. CPU utilization equals total burst time of process, preemptive scheme formulas. Waiting time equals last submission time minus arrival time, minus finished burst. Let's discuss first the non-preemptive scheme. Algorithms. FCFS algorithm. First come first serve algorithm. The simplest CPU scheduling algorithm. Here's an example of FCFS in a situation. Let's call the cars process 1, or in short, P1, and so on. This situation shows that even if the car in front P1 is slow because it's crushed or something, the other cars will have to wait because it's first come first serve. Gantt chart is a graphical representation of how a process was scheduled. Here's an example of FCFS algorithm. We have process P1 to P4. Each have arrival time at 0, 2, 3 and 4 respectively, and have burst time at 5, 8, 15 and 10. Here's the Gantt chart of first come first serve algorithm. The Gantt chart always starts at time 0. And P1 is the first because P1 arrive at time 0. And therefore and so on. Here's the solution we get for waiting time, turnaround time, throughput, and CPU utilization. Please look to your heart's content. P.S. The response time is the same as waiting time. Shortest job first, SJF. This algorithm is very particular with the length of CPU burst a particular process maintains. When the CPU is available, it is assigned to the process with the smallest CPU burst. Here's an example of SJF in a situation. We can see that the sad boy is the first to give his test paper to the teacher because he got the lowest score. And the happy girl is the last because she got the highest score in the test. SJF algorithm means that the lowest number shall be first. Here's an example of SJF algorithm. We have process P1 to P4. Each have arrival time of 0. And have burst time 10, 8, 15, and 3. Here's the Gantt chart of SJF algorithm. As always, it starts at time 0. The first process is P4 because P4 have the lowest burst time. And if they're process that have the same burst time, it's called tiebreaker and use FCFS. As you can see, here's the solution we get using the formulas in waiting time same as response time, turnaround time, throughput, and CPU utilization. Look until your heart breaks.
created using Powtoon.